Hello, it's Jim from JetsonHacks.com. Today's screencast is a quick tip about how to use nvpmodel on the NVIDIA Jetson AGX Xavier developer kit. Let's get started. One of the first things that you want to do when you start developing on the Xavier is to set the nvpmodel. nvpmodel is a command line tool which allows you to set the performance parameters of the Xavier. One of the ways to think about this is the compute performance envelope within a given energy budget. On the Xavier, there are 4 default energy budgets. One is 10 watts, the second is 15 watts, the third is 30 watts, and then there's an unrestricted mode. There are 4 different compute elements that we control on the Xavier. The first is the CPU complex. There are 8 cores altogether. Of course, one must be online at all times. The other 7 can be online or offline. You can control the frequencies on which these CPUs run. The second processor component is the GPU. You can also control the maximal frequency of that. The third processing component on the Xavier Tegra chip is the deep learning accelerator cores. There are 2 of them. You can bring them online or offline and set their maximal frequency. And the fourth compute processor is the vision accelerator. There are 2 cores of that. Online and offline you can choose, of course, and set the maximal frequency. And then you can control the external memory controller, which controls how fast you talk to the external LPDDR4 memory. On JetsonHacks.com, we have a handy little table that helps us decode it. Here are the 7 different modes that are offered. So let's take a look on how to run this. Let's look and see which model we are currently using. We are currently in mode 15 watt, which is the default. We can look that up in our little table. It's mode ID, number of online CPUs, we have 4. Here's the clock speed. We are using all of the texture processor cluster on the GPU. We're using both of the direct learning accelerator cores. We're using one of the vision accelerator cores. And then we have our memory maximal frequency, which is this. You can see that there's a 10 watt mode, a 15 watt mode, and then there are 4 different 30 watt modes. You can characterize these by the number of CPU cores, 8, 6, 4, 2. They all use the entire GPU and the same amounts of the deep learning and vision accelerators. Notice how they juggle the CPU frequencies. If you're using all 8 cores, then you run at 1200 megahertz. If you're only running 2 CPUs, then you run it flat out, basically 2100. The trade-off here is that you're only using 2 cores, but they're going at maximum rate. And then you have the maximum power budget, which is basically everything is on and going as fast as possible. When we use our system monitor, you can see that we have 4 CPUs online. Let's switch modes. We'll switch over to maximum performance, which is mode 0. You'll notice that our system monitor did not change. That's because it doesn't update dynamically. Let's close it and reopen it. Now you can see that we have all 8 CPUs online. There's a script on the Jetson which is helpful also. Let's run it real quick. If we pass show as a parameter, it will tell us the number of online CPUs, the GPU frequencies, and EMC, which is the memory controller. You can also define your own modes. Let's close this. The modes are kept in /etc/nvpmodel.configuration. Okay, let's take a look at mode 15 watt. You can see that there are 4 cores online. You can set the minimum and maximum frequencies of the cores on a per core basis, GPU frequency, deep learning, and the vision accelerator. And then EMC is the memory controller speed. Let's close this. The other thing that Jetson Clocks does is sets up the performance to be maximum in the given mode. So let's run it for this particular mode. You can see the difference. Here's what it was before we started up here, and then here's its current configuration. We basically cranked up all of the clocks on the CPU to the maximum value. We went to the maximum frequency on the GPU and on the memory controller. And we turned the fan on. It's going fast and it is loud. That's basically how you use nvpmodel. It gives you a little bit of insight. If you like this video, give it a thumbs up. If you haven't yet, please subscribe. Thanks for watching.